All right, so today's date is Thursday, September 26, 9/26, 2019. Today we're talking about powers of complex.
You got the date wrong.
Ooh.
Oh, man.
Yeah, I noticed that too.
Sure, log it.
For sure.
Raise your hand if you caught the extra credit point. James, log it, 70 XP.
Oh, I need you to sign.
I want to do my.
Raise your hands again for James. Raise your hand for James.
I got the one.
All right, quiet raise hand. What is our objective today, Eva?
Evaluate complex numbers raised to a power and roots of complex numbers.
There it is. So you guys have the basic idea down from the warm-up, but it is a little bit more complex than I made it out to seem in the warm-up. So one is going forward. One is going with powers, and then on the backside we have roots. There's generally two strategies, but they're both pretty straightforward. As long as you have, if you know 1-11 and everything before that, and you have it down like 5 out of 5 or even 4 out of 5, then this shouldn't be too hard of a lesson. If you kind of forgot some of those things, this is going to be a little bit hairy. We'll see. So power strategy. If you see some complex number, a plus bi, to the power of n, that means it's a power because you have a power right there. So if you have that, then you are going to be doing steps 1 through 3. So step number 1, find the modulus and argument. You guys should know this. What is the modulus? The formula for the modulus if I have a plus bi. Something with a, something with b. Say it louder. There it is. You do a squared plus b squared from Pythagorean theorem, then you take the square root to get c by itself. There it is. Thank you, James, for logging Sego's XP. And Sego, remember to grab that before the end of class, because otherwise I'm going to lose it.
Oh,
What?
no,
James has it. Thank you, James.
Thanks.
What about the theta, our argument? Let's only use quiet raise hands from here on out. If you do not use a quiet raise hand, you are going to lose HP. Quiet raise hand. What is theta? Only 2 people. Also, those 2 people are already in. No cards.
Oh wait, I read the thingy.
Eva, yeah, we'll turn your card for this one.
Arctan.
Arctan
B over A.
of b divided by a. Perfect. So everyone, you have to have these formulas memorized. We've been using them over and over, so hopefully you're just memorizing it even if you're not intending to do that. But there they are. So that's the first step. You're basically, I can even simplify this down even further, but then you'll lose the formulas. Here's how I simplify this. Ready? Convert it to polar form. That's doing step 1. Then you take we'll convert it to polar form because it's easier to multiply in polar form, and taking powers is repeated multiplication. So convert to polar form, then take the power. You're done. Unfortunately, Khan Academy wants it back in rectangular form. So convert to polar form, take the power. So now we're going to actually take the power. So in the warm-up, we already discussed this, but you're going to take the modulus of z, and then you're going to take it to the power of n. So if I come back to the warm-up all the way back over here, if we square W2, you're really doing 16 to the power of 2, or 16 to the power of 3 if I'm cubing it. So you take it to the power of 3. And then because you're repeating your addition, repeated addition is the same thing as multiplication. That's why I'm multiplying theta. So far, so good?
Yes.
I'm hoping that everyone's at least 3 out of 5 up to this point. So, and then finally, you have to convert it back to rectangular form, which means you have 2 options. Your first path that you should always try is use a special right triangle. If it says do it exactly, you're definitely going to be using a special right triangle. 45, 45, 90, 30, 60, 90. And if that doesn't work, if they give you like an angle of like 41, 41 is definitely not a special right triangle, then you're going to have to use a different formula. But first, let's label our special right triangles. A 45, 45, 90, if let's say I have x here, then what is this length and this length? Quiet raised hand. Who knows these 2 lengths of a 45, 45, 90 if one of the legs is x? Andrea. There is x root 2. Thank you, Andrea.
Oh, 2.
And what about the 30, 60, 90? I'll give it to you. 30, 60, 90. Teflon, yeah. If I have the short leg as x, then what happens? Forgot? Stego?
What's the cube root of x?
Not cube root of x, but x squared of 3. And x squared of 3, does it go in the longer one or the shorter one? The leg or the hypotenuse? Good guess, but it was the leg. So it's x squared of 3. And therefore, Stego, the hypotenuse is 2x, exactly. And this is your diagram that tells you if I want to go from 2x to x, I need to divide by 2. If I want to go to x root 3, multiply by square root of 3. All right, let's talk about our trig. If I have a bad angle like 41, I need to use trig. What will give me the real coordinate, or the x coordinate if you're thinking about physics or calculus? What trig function gives you the x or the real? Is it cosine or is it sine? It is indeed cosine.
Oh gosh, thanks a lot.
But you also lose HP because I made it very explicit. If you shout out an answer, you lose HP. So cosine of your theta, and don't forget to multiply. If you're in calculus, you say dinner. But in here, you would say the modulus. So let's say that our modulus was, I guess you can say absolute value of z. So don't forget that, let me move this over a little bit. You can write it to the right-hand side if you want. Usually we write it out front. Sometimes we say r cosine of theta. I'm going to say absolute value of z cosine theta. So I'm going to give the XP to Teflon if James can get that guy. Teflon got the XP, 50 XP. What about B? Can someone give me the formula for B, Eva? There's no, so B already has an I next to it. I'm just looking only at B. So sine of theta multiplied by, no, look at your formula up here.
Absolute value of Z.
What is that called? Absolute value of Z. The modulus, exactly. So now you have your formulas. So going forward, you have everything. You just need to follow those steps now. So we need to evaluate the following expression. Your answer must be exact. And let's do a practice problem, and then we'll go down the curve of forgetting, and then I'll let you do example number 2. I want to do example 1 and show you some videos after example 1. So evaluate the following expression. Step 1. Who's doing it? Step 1. Literally read step 1 and tell me what to do. Read step 1. James.
Find the modules,
Modulus, yeah.
modulus and argument.
Okay, what is the modulus? Absolute value of z. The modulus here is what, James? Just use the formula. Plug them in. Square root of what?
Square root of 3 over 2.
Good. That thing, quantity.
Squared
Good. And then plus.
plus 3 square root of 3
Yep.
over 2
Quantity.
power of 2.
There it is. Thank you, James. So I'm going to work on the modulus first. We'll work on the argument later. I'm trying to convert this thing into polar form. That's the whole point. Once we convert to polar form, it's really easy to do powers. Nice shot. So can someone else tell me what happens when I do that? What is the modulus? Can someone go step by step to tell us what that is? Who wants to do that? Is there a quiet raised hand so I don't have to deduct HP? Who wants to do it? I'm going to cold call on someone that has a card if no one volunteers. Yeah, that's fine. I think Chris is the only one that has a card, so I'm going to automatically call on Chris if no one volunteers.
No, I still have my card.
You participated though.
Oh, I did.
Yeah, you should have your card in. I'll tell you.
Ready?
Yeah. So Evan should have your card in. All right, Chris, go for it. Square this thing. What is 3/2 squared? Square the top. Square the bottom. Good. 9 over. Good. Plus. Square the 3. 9. Square the square root of 3. Nope, just 3 because they cancel out, right? And then all over. And then all of this is square rooted. There it is. And Chris, I'm not done with you yet. 9 plus 9 times 3 is 9 times. If I have 3 9s and another 9, I have how many 9s? I'm adding them, not subtracting. If I have 1 9 here and 3 9s here, I have a total of how many 9s? 3 9s. If I have 3 apples and I get another apple, I have how many apples? 4, thank you. 4 divided by 4, and then these 4s cancel out. Shwink. Or you could have done 36.
What did you just do?
So I have common denominators. Does everyone agree?
Yeah.
That means I can add the numerators.
Why did you put a 4?
Can't you just do the 9 times 3 and then it's 27 plus 9?
You can do that. Sure, let's do that way.
Why do you do 9 times 4?
Because I'm counting the number of 9s. How many 9s do I have?
You have 2 9s.
I have 1 9 and 3 more 9s. A total of 4 9s.
Oh.
4 9s is also 36. And then your 4s cancel out. You don't even have to do the math as long as you can see counting apples. I'm counting apples, I'm counting 9s.
Here's the 9 times 2 plus 9.
Yeah, that was pointed out, so let's just do that. 9 times 3 is 27, plus 9 is 36. So I get 36 over 4. I need to take the square root of that. Well, what is 36 divided by 4? What is the square root of 9?
3.
Woo! And I should have said shut it out, but yeah, you guys are good. So the modulus is 3. We're converting to polar form. We're halfway there. We now need to take our theta, find our argument. Quiet raise hand. What is our argument? So can we add to the notes here? Right here, up here. Let's add to our notes. Use special right triangles. Right triangles. You should first always try to use a special right triangle. And this is going to be a case where you can use a special right triangle. I can see that because I went from, let me scroll so you guys can see. I went from 3 over 2 and 3 over 2, but this one has an additional square root of 3. Multiplying by square root of 3 sounds familiar. Going from x to x root 3, I'm multiplying by square root of 3. It sounds familiar because I guarantee that like 99% of the problems on Khan Academy are going to be special right triangles. I'm feeling confident. I'm going to say 100%. 100% of them are going to be special right triangles. So get used to using special right triangles. If you see a square root of 2, you're probably using 45, 45, 90. If you see a square root of 3, you're probably using a 30, 60, 90. The question now is it a 60-degree angle or a 30-degree angle? So let's go ahead and sketch this thing on the side. Over here under example 1, give yourself the complex coordinate plane. Go ahead and try to graph 3 over 2 plus 3 square root of 3 over 2. And the easiest way to think about that is ignore the 2's. Try to graph 3 and 3 square root of 3. Oh, I totally forgot my I, didn't I? Oops, teacher error. James, can you give everyone 70 XP? I should make Fiona absent. You can give her XP, but if I ever receive an email from Fiona saying I caught that, I'll trust her and she'll just get the XP. But for now, bye Fiona. All right. So did I make another mistake? Oh my gosh, I have to give everyone 70 XP again. Okay, James, another 70 XP. There should be an I there.
Why are you giving us 7 XP if we didn't find it?
I found it. If I find it,
No, isn't it only if we find it?
okay, fine, we'll change it to that from now on.
I thought that. I
No,
said
don't
that-
listen to Chris.
I
Don't
thought
listen
that
to
Can we have a democracy?
Don't
Not
change it.
change it?
All right. Anyway, we're moving down here to theta. Theta, I'm not going to use arctan. I'm going to graph this. Did you guys graph it okay? Okay, everyone is going to do this. You have two options. You're either at 30 degrees or 60 degrees. Everyone do it now. Where are you? If I'm graphing 3 over 2 plus 3 squared root of 3i over 2, where am I? Am I there or there? Everyone do it now. Where am I? Chris, that's 90 degrees. Come on, 30 to 60.
Wait, what?
You're either at 30, which is basically flat, or 60, which is basically up. Everyone's right but Chris. It's 60 degrees.
You see, I was at 90.
You were at 90 because you were straight up.
So I went down 30.
That's
30 is
90.
No.
Chris, oh my God. Okay, so in your notes, graph it. There it is. Obviously, 3 is smaller than square root, or 3 times square root of 3 because we know that square root of 3 is bigger than 1. If you don't believe me, square root of 3 is 1.7, and then 3 is obviously, if I multiply that by 3, I have 5.19 versus just 3. So 1 is 5.19, 1 is 3, 5.19 is bigger. So I graphed it on my complex coordinate plane. I know what the dimensions of that triangle are if I make a line down to the real axis, a line that represents the argument, the distance from 0. And I know that the x, or not the x, sorry, we're in complex plane. So I know that the real dimension is 3 halves. Label it 3 halves. I know that the imaginary direction is 3 square root of 3 halves. How do I get to the well, I don't need the hypotenuse. The hypotenuse would have been really easy to get to if we sketch it immediately. We wouldn't have to do all that junky work. To get from 3 square root of 2 to the hypotenuse, I would have had to do what operation? Shout it out. Multiply by 2, yes. Multiply by 2. If you multiply by 2, you'll get it, and we could have just got there right from the end. 3. The argument was, or not the argument, the modulus was 3. So that would have given us 3. And what angle is this? Quiet raised hand this time. What angle is this? We just did this. I should be seeing like everyone's hands up. Why is only half the class? Yes, Chris. It is indeed a 60-degree angle. Write it down. This is a 60-degree argument. Okay, we have now basically converted to polar form. We could write it out, but that takes too much effort. This is in polar form. Now I need to use my idea here of calculating. I'm doing a power for the modulus, and I'm multiplying by n, in this case, by 3 for the argument. So, what is our new complex number? We can write it out just finally like this. We say that our complex number in polar form is going to be, well, I have 3 to the power of 3. What is 3 to the power of 3? 27 times cosine of, well, what is this angle in here? What should it be? Theta times 3, what is that? Someone help me out. Quiet raise hand. No, Stego, quiet raise hand.
Before you finish your sentence.
It's always assume quiet raise hand unless I say otherwise, Stego. Cosine of? Stego?
180.
180, there it is. 180 degrees. And then plus I sine 180. I sine of 180 degrees. Whew, all right, so we have our correct answer. We just now need to do step 3, convert it to rectangular form. So again, always draw your coordinate plane or your complex coordinate plane. Where is 180 degrees? Point to it with your arm. Where's 180 degrees? Where is it? Well, you have one of them, right? Yes, you should be doing left arm out to the side, because 0 degrees is your right arm. Left arm straight out is correct. There it is, 180 degrees. And what is our modulus? What is our distance from 0? What is our distance from 0? It is, Andrea?
27.
There it is. Thank you, Andrea. 27. So this distance here is 27. Quiet raise hand, what is our final answer? We did all that work. What is this? What is the coordinate of that point? Is it something plus I? What is it in rectangular form? Quiet raised hand. What is the coordinate of that? There's no imaginary component. It does not go up and down. It's purely on the real axis. But it's going left, Chris.
0 minus 27.
I mean, you're close. One of those is right, but what is the answer? There's no imaginary component. So it's just, you can think of it as fill in the blank. You need to fill in the blank here plus 0i, which means you ignore that. What is the number that goes in there, Chris? Close. You also get your XP. James. It's going to the left, James, so it's not positive 27, it's... There it is. Our answer is negative 27. All right. So I'm going to let you go down the curve of forgetting, but before I do that, any questions on example 1?
Why is it negative?
It's negative 27 because left and down is negative. Left is negative, negative 27. Down is negative. Up is positive, right is positive. Other questions? All right, so, say again?
No.
Okay, let's watch some videos. Take a break, go down the curve of forgetting. So, again, Khan Academy is using 3 blue, 1 brown, which are some really good videos. So, what happens if I multiply by I? Have we ever thought about that? Multiplying by I? Multiplying by 2 is pretty easy. What does multiplying by I mean? So if I mark my point 1, where should 1 end up if I multiply by I?
In the same spot.
No. 1 times I is
Hi.
I. So let's see what happens. If I multiply by I, it should rotate by 90 degrees. Which is kind of cool. Multiplying by I is rotating by 90 degrees. Okay. Why did it not dilate? Why didn't it get bigger or stretch out?
Because there's
Yeah, for all these videos, just shut them out. It's not going across.
The real.
Kind of. What? If I'm multiplying by I, what is the argument?
You say it.
What is the modulus of I? What is the distance that I is away from 0? 1. The modulus of I is 1. 1 is the distance that I is from 0. So if I multiply by 1, I am not moving out at all. It's just a pure rotation. I'm not stretching it. Okay, let's look at what happens when I do I to the power of 2. All the way back from algebra 2, we know the definition of I squared. What is I squared? Let's see it. If I multiply by I squared, I first multiply by I, which goes up there. If I multiply by I again, multiplying by I squared is the same thing as multiplying by -1. When you are multiplying by I, you're doing a 90-degree rotation. Multiplying by I squared is a 180-degree rotation. All right, continuing on. So now we're doing powers of complex numbers. So 1 plus I squared root of 3. Well, the modulus of 1 plus I squared root of 3 is 2. So what should happen? What should happen when I rotate? I'm rotating by 60 degrees, which is the argument, and I'm also stretching by a factor of 2. Let's watch it. So here's 1. I'm going to multiply by z. This is going to map to z, and everything got stretched out by a factor of 2 with a 60-degree rotation. If I do it again, it's stretching it even further and rotating it even further. Again, I go once, but then again, because I'm squaring it, and it comes out there. So it's the same idea of yesterday, but stretching it twice, or doing it multiple times. So let's do it 8 times. Ooh, 8 times. So we're going to multiply by the number 1 plus I. There it is, 1 plus I. So once, twice. Look how far out that first blue dot is getting. This first blue dot is getting further and further. Because the modulus is square root of 2. It's getting square root of 2 bigger each time. It's getting bigger and bigger by square root of 2. Even bigger by square root of 2. Even bigger by square root of 2. Even bigger by square root of 2. Where are we going to end? Does anyone know?
No way.
360.
We're going to end by the modulus to the power of 8. Well, we had the square root of 2 was the modulus. So what's the square root of 2 to the power of 8?
What?
What is the square root of 2 to the power of 8? It's 64. No, it's 8, sorry. Square root of 2 to the power, so square root of 2 squared is 2. And then I multiply to the power of 4 again. 2 to the power of 4 is 64. No, 2 to the power of 4 is, what am I saying? It is 64, isn't it?
2 to the power of 4 is 16.
It's 16. Okay, it ended at 16. I don't know why I was being messed up. Oh yeah, and it even tells you that there. What you're doing is square root of 2 8 times, so that's 2 to the power of 4 is equal to 16.
Do I get credit?
Sure. We're about to go backwards. But before we do that, we're going to go forwards again. So I let you go down the curve of forgetting. We're coming back to the notes. I want you guys now to try to do example 2, using the same steps that you did in example 1. All right, good luck. All right, we're back. Mr. Sindel is going to be in charge of example number 2. So the first thing that I see is that this is going to be a special right triangle because I have a square root of 2. I'm going to graph it. When I graph it, I know I have a negative and a negative. They're both the same number, so they both come out here at about a 45-degree angle. The first thing is even easier than the second thing, I guess. I'm going to find the argument first. The argument is pretty straightforward. I'm going 90, another 90 to get 180, another 45 to get 225. I know that my theta is equal to 225 degrees just from looking at the graph. The next thing that I need to know is what is this triangle? Well, this triangle has a length of 5 square root of 2 over 2, 5 square root of 2 over 2. And I know to get from the leg of a 45, 45, 90 to the hypotenuse, I need to multiply by the square root of 2. So the next question becomes, what is 5 square root of 2 over 2 times square root of 2? Well, these square root of 2's are going to kind of cancel each other out, and it just turns into 2. So this is going to turn into 5 times 2 over 2, and these 2's are going to cancel out. I know that my modulus already, my absolute value of z, is 5. So there's a 2 on the top and a 2 on the bottom. 2 on the top from the square root of 2 times square root of 2. And I know that my argument is going to be 5. From there, I'm going to use the formula that I'm going to square the 5 and double the argument in order to figure out where I land, because this is to a power of 2. If this was a 3, both of these would be 3. If it was a 4, both of them would be 4. So if I come back here, 225 times 2 is 450. 5 squared is 25. So now I need to graph this thing. Graphing 450 degrees is a little bit difficult, but what I can do is I can subtract 360 degrees. I'm allowed to subtract as many 360 degrees as I want. I could do minus 360 again, as many times as I want, because I'm still aiming at the same spot. So minus 360, I get 90, so my graph should look like this. My graph is up here at 90, and I have a modulus of 25 away from the origin. So this is a distance of 25 right here. This distance is 25. Well, what is that number? There's no real component because I'm nowhere to the left or the right. So it's going to be 0 plus, and then it's 25i. So the answer is just 25i. If you know how to do example 1 and example 2, you are ready for the homework assignment. There's only one homework assignment. Half of them are going to be like this. Half of them are going to be like the back side. Give me a fist of 5 going forward. How well can you take powers of complex numbers? The fact that everyone is that high is really pretty awesome. 0. I didn't learn about this stuff until my 3rd year of college studying
I
math.
was going to say your 3rd year of high school. I was like, same.
You guys are 4 years ahead of Mr. Sindel, which is just, it's very impressive. The fact that you can get this. This is hard stuff. This is a college class right here.
Is anyone going to be smarter than you when I'm your age?
Yeah, it could be in that. All right, so we're on the back. We're taking square roots. Square roots, in my opinion, are harder.
Nice.
So I'm sorry, but here it goes.
We only have like 3 minutes.
We only have 3 minutes. We get out of here at 1:02. We have 4 minutes. Okay, we're gonna go nice and fast.
Tomorrow.
Save it for
Tomorrow.
Tomorrow's Friday. I'm gonna go through this. Regardless of what happens, the homework is going to be due on Monday. I will record the rest of this video later. But yeah, we still have like 3.5 minutes, so let's do as much as we can. If you see this form, z to the power of n is equal to some number or some I, then you are going to be doing roots. You need to first rewrite them both in polar form. So this is how you write polar form. The z to the n, this stuff on the left-hand side, is rewritten like this. So the left-hand side looks like this exactly every single time. It's over and over and over again. It's going to be the same thing, except your n is going to be a different number. That n is going to be like 5. So that's going to be a 5, that's going to be a 5, that's going to be a 5. But it's the same thing over and over and over for the left-hand side, aside from the fact that n changes to a number. So far, so good. The right-hand side is going to be really easy. They're always going to choose a nice number like 3 or 3i or negative 3i. Those are always going to be like 90 degrees. They're always going to be an exact modulus. So for example, I want you guys to write, what is 3i? What is 3i in polar form? Out loud. Shout it out. What is 3i in polar form? What is the argument? What is the distance from 0?
90.
Sorry, the modulus. The modulus. What is the distance from 0? How big is this thing? 3 times cosine. What is the angle?
90.
90, blah, blah, blah. So you got it already. You should be able to do it in your head. So the right-hand side, you can make a note here. This is easy. It should be easy over and over. If I make it hard, then I'm being really, really mean, and I will never do that to you. Even in college, they usually make it pretty easy. So next, you need to solve for the modulus and the argument by setting them equal to each other. So essentially what I'm going to have is my polar form equal to a polar form. This r to the n is going to be equal to whatever your modulus is from there. Your n times theta is going to be equal to whatever you had right there. The trick is, when you're writing your stuff on the right in polar form, you're not just going to have 90. I know you guys all said 90. You're really going to say 90 plus 360k. Because if I look at 90 and I go 360, I'm still at 90. If I go 360 again, I'm still at 90. I can go, as long as k is an integer, this works out. If you choose 2, it's going like this, 90. Back up to 90. You're still at 90. That's why I'm going to add 360 degrees. So, we have 1 more minute. This is kind of cool too. Whenever you have to convert back to rectangular form, in college I did have to do this, but you do not have to do special right triangles all of a sudden. They want you to only use trig for Khan Academy. In fact, the other way that we can say this is they do not want you to use trig when you're doing this form.
What? Oh, okay.
So for the first firm, going forward, they don't usually want that. I'm only 50% sure about that. But you definitely need to have these rewritten. The absolute value of z times cosine of theta, absolute value of z times sine of theta. I will do example 3, and that will be it. So I'll do example 3 tonight. I'll have it done. I want to get it done after school. I'll probably get it done around 2 o'clock, I'm guessing. All right, so we are back, and let's do example number 3. My computer is bugging out. Don't know. Oh, that's what's going on. The cord is on top of the tablet. All right, so we need to find the solution to this guy. Z to the power of 6 is equal to 64i, so I am finding roots. So step 1 is I need to rewrite both the left-hand side and the right-hand side in polar form. The left-hand side, z to the power of n, is going to look like this. It's almost exactly like this. So z to the power of 6 is going to be r to the power of 6 times, in parentheses or square brackets, cosine of 6 theta, plus I sine of 6 theta. All right, so that's the left-hand side. Here goes the right-hand side. So it needs to be 64i. Where is 64i? If I go ahead and graph 64i really quickly, 64i, I goes straight up, not on any of the other axes, and it goes a distance here of 64, so it has a modulus of 64. So write the modulus first, the modulus here. So 64, and then I'm going to multiply that by cosine of the angle. Well, the angle is going straight up, so that's 90 degrees. Cosine of 90 degrees plus I sine of 90 degrees. So far, so good. I haven't done anything too tricky yet. I've just converted them both to polar form. That is step 1. Ooh, I messed up though, because this needs to be 90 plus, sorry about that, this needs to be 90 plus 360. So the idea here is if I rotate 360 degrees around, whoop, then I come right back up here to 90 degrees again. So 90 is the same thing as anything plus 360 times, I don't know, some k, I guess. Did I say k up here as well? Yeah, 360k. K, assume that k is a whole number. It can be an integer. It can be -1. It could be 100. Some whole number. So cosine 90 plus 360k plus I sine of 90 plus, I'm running out of room, 360k. And square bracket, just barely. All right. So now that I have that, I need to solve. I think that's step 2. Solve for the modulus and argument. So right here, r to the power of 6 is going to be equal to 64. You're just kind of pairing them up, matching the left and the right. So if I write down here, r to the power of 6 must be equal to 64. And from there, it's pretty straightforward to solve. Like what times what times what times what times what itself 6 times will give you 64. And the answer should be pretty straightforward. It's not 1, because 1 times 1 times 1 times 1 is just still 1. If it's 3, it's going to get really big. For example, 3 to the power of 6 is like 729. Way too big. But 2 to the power of 6, however, 2 to the power of 6 is indeed 64. So if I take both sides to the power of 1/6, I guess that's how you technically solve this. This side to the power of 1/6, this side to the power of 1/6. If you want to do that in your calculator, you can even do it with your spotlight search. If you do 64 to the power of, in parentheses here, 1 divided by 6, you get 2. So that's how you do it on your spotlight search. And of course, if you want to come over to your calculator, that's the wrong one. Come here to my calculator. Open desmos.com/scientific. You don't need to see those cards either. If I want to do the cube root, it's this nth root button where I can change this to whatever I want. So 6th root of, and I come back over here, 64, and it tells me that is 2. Anyway, so we definitely know that r is equal to 6. R is equal to 6. R is equal to 2. And that's half of the battle here. And now I need to solve for theta. So this 6 theta, let me do it in black. This 6 theta and this 90 plus 360k, set those equal to each other because those are the two that match up. So I'm going to do that. I'll do like a little squiggly. I'll do it over here on the right hand side to save some room. We have 6 theta is going to be equal to 90 plus 360 times k. All right, now I need to solve for theta, not for k. K, we know what k is. It's some integer. Theta, we don't know. So let's go ahead and divide both sides by 6 both sides by 6, there we go. Divide by 6, divide by 6. So we have to divide each of these by 6. And when I do that, let's use yellow here. I get theta by itself because the 6 cancels out. And 90 divided by 6, that is 15. Because I know 45 divided by 3 is, I'm just reducing top and bottom divided by 3, it's 45 over 3, and 45 and 3 turns into 15. And you can always use a calculator on this one. Calculators are okay. And then on this one, 360 divided by 6 is 60k, so plus 60k. So we're basically there. I mean, we now have to follow what Khan Academy is telling us, or what the problem is telling us. It needs, the argument here, the theta here, has to be strictly between 180 and 270. So what we need to do now is we need to choose a whole number to plug in for k. Let's choose 1. 1 times 60 is 60. 60 plus 15 is 75. Is 75 between 180 and 270? No. Let's try again. Okay. So let's try 2. If I plug in 2, that's going to be 60 times 2 is 120. 120 plus 15 is 135. Still not there. Let's try 3. If I plug in 3, 60 times 3 is 180. 180 plus 15. Now we're in between. Now we're at 195. So we can choose k to be whatever we want as long as you're in between these two. Technically, there's an infinite number of solutions because k is an infinite number of answers or an infinite number of whole numbers. So I'm choosing k to be 3. The way that you choose that is just make sure that you choose a whole number that is between here and here. We found that is going to be 3. So we know here that, I'll choose a black here again, I guess. Theta should be 15 plus 180 in this case, and theta is going to be 195. All right. So we have all of that done. We've solved for the modulus, solved for the argument. Now we are in finally step 3, convert to rectangular form. And this one, I should have said here in the instructions, round to 3 decimals or thousandths, THOU, thousand, and then we will get it. So if I plug in my formula, again, A should be equal to my R cosine of theta, and B is equal to R sine of theta. We know that this is going to be equal to R, which is, we found that to be 2, so it's going to be 2 cosine of 195. And this is going to be equal to 2 sine of 195, and we have to round those accordingly, so let's do those really quick. 2 and 95, so 2 cosine, caps lock is on, 2 cosine 195 and 2 sine of 195. And there we have it. The answer here, if we're rounding to 3 decimal places, is negative 1.932. So negative 1.932, that came from the cosine, and minus 0.518. Minus 0.518i. Final answer, box it, the end.